Welcome to the Deep Dive. Today, we're jumping into something pretty cool, I think. It's a presentation called Virtual Robot Race. Our job today, break it all down, make it super clear, energetic, like we're explaining it to someone maybe in middle school. Think fun examples, easy explanations. The usual goal here, shortcut to getting smart on complex topics. Okay, let's unpack this.
Yeah, and what's fascinating here, I think, is how it mixes some really cutting-edge stuff, AI, simulation, with something that's just plain fun. Competition.
Right.
Plus, it connects directly to, real-world skills. Things like computer vision and control, which are actually super important out there.
Absolutely. So let's kick off with the very first slide. It says, welcome to the virtual robot race. Race your algorithm and AI robot race easy, fast, low cost. You train your own AI. Okay, so the main idea seems to be imagine a race, right? But you aren't driving. You're building the driver, a robot driver. And it's all virtual, so it's happening inside a computer. And the key part is you teach this robot using AI.
Yeah, AI, artificial intelligence.
Can we break down AI real quick? Super simple.
Sure. Think about teaching a puppy a new trick.
Okay.
AI is kind of like that. But instead of a puppy, it's a computer program. And the trick isn't sit or stay. It's driving a race car.
Gotcha. And algorithm, that sounds technical.
It does, but it's really just a fancy word for the instructions. The step-by-step recipe you give the computer to follow, that's your algorithm.
Okay, recipe, I like that. And the easy, fast, low cost part.
That's a big deal. It means you don't need, expensive physical robots or your own racetrack.
Right.
It's all software, so it's a really accessible way, a great way, actually, for people to start learning about AI and robotics without breaking the bank or needing a lab.
Makes sense. And what about alpha release?
Yeah. That just means it's an early version, like a first draft of a book, maybe?
Okay.
They're putting it out there for people to try, find bugs, give feedback, help make it better before the final version.
Got it. So moving to the next idea, slide 2 is pretty straightforward. What is virtual robot race? A race where AI drives your robot in a virtual world.
Yeah, just reinforcing that core concept.
So it's really about your AI being the driver in this make-believe computer world.
Exactly.
Maybe like a super fancy video game. But instead of you using the controller, you're actually writing the code that is the controller. Does that sound right?
That's a great way to put it. You're the brain behind the controller.
Cool. Okay, slide 3 gets into why it's exciting. Seems like it's about learning cool tech skills while having fun.
Definitely. It lists things like learning computer vision, control, and data-driven modeling. Plus, you get to compete.
Let's tackle those terms. Computer vision.
Right. Imagine teaching a computer to see and understand what it's looking at, like our eyes do.
Yeah.
For the robot racer, it's about seeing the track and maybe seeing other cars or obstacles. The slide mentions it uses RGB input.
RGB.
Yeah, just red, green, blue. The basic colors digital cameras use to, see everything.
Simple enough. What about control?
Control is about making the robot do what you want it to do.
Like steering, speeding up.
Exactly. Steering, accelerating, braking all the actions. It's the link between understanding and doing.
And data-driven modeling. That sounds like the learning part.
It absolutely is. It means the AI learns by looking at tons of information data. It finds patterns in that data and then makes decisions based on those patterns.
Oh, like practicing baseball swings over and over. Seeing what hits the ball best.
Perfect analogy. Lots of practice, analyzing what works, getting better over time. That's data-driven learning.
Got it. And all this happens in a simulated environment.
Right. That's the virtual world, the digital racetrack. Think of flight simulators pilots use. It acts just like the real thing, physics and all, but it's safe. No real crashes, no real danger. It's a perfect practice ground.
And the robot uses camera input. We covered that, RGB, and also battery, SoC.
SoC, state of charge. Basically, the robot's fuel gauge.
How much juice it has left?
Exactly. How much battery power? Important for strategy, maybe.
Could be.
Yeah.
And the AI uses this info to predict torque.
Torque. Yeah, that's the twisting force that makes the wheels spin.
Okay.
So if the AI wants the robot to speed up, it tells the wheels to apply more torque, like pushing harder on your bike pedals.
Gotcha. Twisting power for the wheels.
And one of the most exciting things mentioned is see your algorithm win or crash on the track.
Yeah, that immediate feedback sounds key.
It really is. It makes the learning super engaging. You write some code, you run the race, and boom, you see instantly if it worked or, if it didn't.
Learn fast, fail fast kind of thing.
Exactly. And it's important to remember this isn't just a game. These skills Computer vision, control, learning from data, they're used everywhere. Self-driving cars, robots in factories, even analyzing medical images.
Wow, okay. So it's fun, but also builds really valuable skills.
Precisely.
So let's dig into slide 4, how it works. Looks like it uses Unity and Python.
Right? Those are the main tools. Two pieces of software working together.
So what's Unity?
Think of Unity as like the stage manager and set builder for the virtual race.
Okay.
It builds the track, creates the robot's virtual body, handles the physics, how things move, and manages the race rules. And it's constantly sending info to Python.
How fast? It says every 50 meters, 20 FPS.
Yeah, 20 FPS means 20 frames per second. Like how many pictures a movie camera snaps each second to make the action look smooth. So Unity sends what the robot sees and its battery level to Python 20 times every second. Pretty quick.
And Python, what's its role?
Python is the robot's brain. It gets the info from Unity, the camera view, RGB, the battery level, SoC. Then your AI code written in Python figures out what to do.
Like deciding the torque for the wheels.
Exactly. It calculates how much power or torque to send to the left wheel and the right wheel and sends those commands back to Unity.
And how do Unity and Python talk so fast? It mentions WebSocket.
Oh, WebSocket. Imagine like walkie-talkies that are always on, constantly chatting back and forth really, really quickly.
Like a dedicated fast connection.
Yeah, basically. It's a way for them to have a persistent, fast, two-way conversation.
That makes sense.
Yeah.
Now, it also lists different control modes. Keyboard manual control, table-based CSV, rule-based, and AI control.
Yeah, this is really flexible, which is great for learning.
So manual is just, you drive it with your keyboard.
Yep, get a feel for it yourself.
Table-based CSV. What's CSV?
CSV is just a simple spreadsheet file, separated values. So you could literally make a list of commands in a spreadsheet, like go straight for 2 seconds, turn left, and the robot follows it.
Huh. Okay. And rule-based?
That's like setting up if-then rules. If the track turns right, then steer right. If an obstacle is close, then slow down. Simple logic.
And then finally, AI control, where your actual trained AI takes over.
Exactly. That's the main goal. But having those other modes lets you build up to it or compare different approaches.
And crucially, it says it logs data for AI training.
Yes. This is super important. While the robot is running, the system records everything, what it saw, what commands it issued, battery level, maybe its position.
All that data the AI needs to learn.
Precisely. This logged data becomes the textbook for your AI. It uses this history to figure out how to drive better next time. That feedback loop is key for AI development.
Okay, that clears up the how. So if someone listening is thinking, hey, I want to try this, slide 5 covers how to join. First step, visit GitHub.
Right. GitHub is like a giant online library or maybe a shared workshop for software projects.
So you go there to get the project files.
Exactly. You find the virtual robot race project there. Then it says install Python and dependencies.
Python we know is the programming language. What are dependencies?
Dependencies are just other little software bits the main program needs to run properly. Like if you're baking a cake, flour and eggs are dependencies for your recipe.
Got it. Extra ingredients. Then you clone the project.
Yeah, clone just means making your own copy of all the project files from GitHub onto your computer.
Okay, so get the files, make sure you have the ingredients, copy it over, then
you run the simulator, choose which control mode you want to use, and you're off.
And if you get stuck, it mentions join Discord.
Discord is a popular chat app. They have a dedicated channel for this project. It's a place to ask questions, get help from the creators or other users, share what you're doing. It builds a community around it.
That community aspect sounds really helpful for learning something new.
Oh, absolutely. Learning with others is almost always easier and more fun.
Makes sense. Slide 6 looks ahead. What's next? It mentions the alpha version, released now available to test.
Yeah, reinforcing that it's new, it's out there for people to try now.
And they welcome feedback and collaboration.
Which is great. They're not just putting it out there. They want people to get involved, share their thoughts, maybe even help build new features. It's an invitation to be part of the project's journey.
So it's not just about using it, but maybe having to improve it too.
Exactly. It's a chance to collaborate, have your ideas heard, maybe even contribute code if you get into it. Real open source spirit.
Very cool. And finally, slide 7 is the call to action. It lists the GitHub link, the Discord invite, and their official website.
Yep, just giving you the concrete next steps, all the links you need if you want to actually download it, join the chat, or just read more on their site.
So the resources are all there, if you're curious.
Clear entry points to dive deeper.
Wow. Okay. So we've just kind of zoomed through this virtual robot race world. We talked about how you use AI to drive a robot in a virtual race, what cool tech skills you can pick up, and how actually it seems pretty easy to get started.
Yeah.
So what does this all mean? What's the big takeaway here?
Well, I think what's really fascinating is how projects like this make something pretty complex, AI, robotics, simulation, much more accessible. It lowers the barrier, and it makes you think, doesn't it? If we can use these tools, computer vision, control, learning from data, to teach a virtual robot to master something like racing, well, what else could we teach AI to do? What other really tricky real-world problems could we start tackling by building and training AI agents, maybe starting in these kinds of virtual environments? What problem would you, listening right now, want to solve with an AI you built?
That is a great question to ponder, a really powerful thought. Hopefully this deep dive gave you all a good look into the virtual robot race and maybe spark some interest in these really dynamic field. Thanks so much for joining us on the deep dive. Keep exploring, keep learning.
See you next time.